Hi class. In this mini lecture we're going to discuss effect size. As a reminder, effect size is just a quantitative measure of the strength of some phenomenon. So if you have, say, two groups, an experimental or control group, effect size is really just a measure of the degree to which the mean of one and the mean of the other differ in terms of the standard deviation of the parent population. Effect size is often statistically annotated as an italicized D. And for the values of D, there is no universal standard for describing the strength of the effect size. So just as a general rule, if you have an effect size of 0.20, you would describe it as small. If you have an effect size of 0.50, you would describe it as medium. And an effect size of 0.80, you would describe it as large. An effect size, as we're going to see in the next lessons, can cue us into how many participants we might need for something. You can think of what does effect size actually mean in terms of differences, say, between populations. So if you were going to run an experiment and you had individuals with schizophrenia and you had normal individuals, and you were going to test for, say, cognitive differences on some measure. The percent of overlap, or the difference between them, the percent of overlap is maybe going to be very small. So people with schizophrenia, particularly if they're not medicated, might have a very large difference from normal controls on some cognitive measures. So the percent of overlap between those two populations is going to be fairly small. In that case, you're probably going to need fewer people in your experiment to actually test for differences between those two populations. If, however, you have something like depression, and you have individuals with depression and you have your normal controls, and you ask them different questions pertaining to depression, people who are not depressed will probably score on some of those items. It won't be uncommon for people in the population to endorse items like I felt blue or I was worried about particular things. It's just with depression, it's maybe on the extreme end of the continuum. So the percent of overlap between depressed individuals and individuals who are the normal controls is going to be much larger. People who are in the normal control group will still experience some of the symptoms that people who are depressed have, and so there'll be some overlap between the groups. So because, with a small effect size there's a lot of overlap, you'll generally need more participants to show a difference between the groups. In terms of what influences effect size essentially, if it is large, a type 2 error is unlikely. So a false negative is unlikely. However, a small effect size might not end up being significant with a small sample. So we talked about the difference between people who were depressed and people who were not. Detecting a difference between those two groups, because the effect size is somewhat smaller, might be harder. You might need a very, very large sample to detect differences between those groups if in fact there's a small effect size between them. The formula for calculating effect size for the difference between two independent means is the mean of the experimental group minus the mean of the control group over the standard deviation, or as you might see it with the statistical annotation, D, effect size, equals the mean of group 1 minus the mean of group 2 over the standard deviation. So let's work out some actual examples and calculate the effect size. So again, as a reminder, here's the formula. So if there's an experiment in which the experimental group has a mean of 12 and a standard deviation of 4, and the control group has a mean of 7 and a standard deviation of 4, we do 12 minus 7, the mean of the experimental group minus the mean of the control group over the standard deviation of 4. And that equals 1.25. If we go back to our table, we can see that a effect size of 1.25 comes in here under sort of very large or extremely large. And another example, if you have an experiment where an experimental group has a mean of 80 and a standard deviation of 12, and the control group has a mean of 70 and a standard deviation of 14, we have 80 minus 70, the mean of the experimental group minus the mean of the control group, over 14, the standard deviation, and that equals 0.71. So our effect size is 0.71. We go back to the table and we look for 0.71, and it's pretty close to large, so we could say that there's a large effect size between the groups in that particular experiment.